In the name of Allah, who is the most beneficent and most merciful. My name is Arid Fatma and I am from BS Chemistry Department. Now I will talk about the third course of SQL, which is Intermediate SQL. Intermediate SQL. How do we manipulate, transform and make the most sense of our data? This intermediate level course will teach us several key functions necessary for to wrangle, filter and categorize information in a relational database. How we expand SQL toolkit and answer complex questions. We will learn the robust use of case statements, subqueries, and window functions. So, this course includes 4 chapters. We will take the case, short and simple subqueries, correlated subqueries, nested queries, and common table expressions, and fourth is window functions. Next is we will talk the case. This is the first chapter of this course in which we learn how to use the case when statement to create categorical variables, aggregate data into single column with multiple filtering conditions and calculate counts and percentages. So this chapter includes basic case statements comparing column values, case statements comparing two column values. In case of rivalry, filtering your case statements, count using case and when, and at last calculating percent with case and average. So first is basic case statement. Create a case statement that identifies whether a match in Germany included FC Bayern Munich, FC Schalke 04 or neither as the home team. Group the query by case statement alias home team. So for example, case when home team ID is equal to 10189, then FC Shark 04 when home team ID is equal to 9823, then FC Bayern Munich. Else other and as home team count ID as total matches from matches Germany. Group by home team. Next is case statements comparing column values. In this, we select the data of the match and create a case statement to identify matches as home wins, home losses, or ties. So, select date, case when home goal less than average goal, then home win. When home goal greater than average away goal, then home win. If when home goal less than average away goal, then home loss. Else tie and as outcome from matches Spain. Case statements comparing two column values. Complete the case statement to identify Barcelona's away team games IDs 8634 as wins, losses, or ties. Left join the team Spain table team API ID column on the matches Spain table. Home team ID column. This retrieves the identity of the home team opponent. Then filter the query to only include matches where Barcelona was the away team. So simple, select m.date t.team long name as opponent. Case when home goal is less than away goal, then Barcelona win. When home goal greater than away goal, then Barcelona loss. Else tie and as outcome from matches Spain as M and left join team Spain as T on home team ID is equal to T dot team API ID where M away team ID is 8634. Next is in case of rivalry. Complete the first case statement identifying Barcelona or Real Madrid as the home team using home team ID column. Then complete the second case statement in the same way using away team ID. So first select date case when home team ID is 8634, then FC Barcelona, else Real Madrid CF and as home. Case when away team ID is 8634, then FC Barcelona, else Real Madrid CF, and as away from matches Spain, where away team ID is 8634 or home team ID is 8634 and away team ID is equal to 8633 or home team ID is equal to 8633. Filtering your case statements. In this example, select the season and date that a match was played. Complete the case statement so that only Bologna's home and away wins are identified. Next is count using case and when. Create a case statement that identifies the ID of matches played in 2012 or 2013 season. Specify that you want else values to be null. Wrap the case statement in a count function and group the query by country alias. Select CNAME as country. Count case when M season is equal to 2012 or 2013, then MID else null and as matches 2012 2013. From country as C, left join matches as M on C ID is equal to M dot country ID, group by C dot name. Calculating percent with case and average. Calculate the percentage of matches tied using a case statement by simply put average. Fill in the logical operators for each statement and then alias your columns as ties 2013-2014 and ties 2014-2015 respectively. Next is short and simple subqueries. In this chapter, we will learn about subqueries in the select from and where clauses. We will gain an understanding of when subqueries are necessary to construct our dataset and where to best include them in our queries. So this chapter includes filtering using scalar subqueries, filtering using a subquery with a list, filtering with more complex subquery conditions, joining subqueries in from, building on subqueries in from, add a subquery to the select clause, add a subquery in from, add a subquery in select. So first is filtering using scalar subqueries. So first of all, what are subqueries? Subqueries are incredibly powerful for performing complex filters and transformations. You can filter data based on single scalar values using subquery in ways we cannot by using where statements or joins. So subqueries can also be used for more advanced manipulation of our dataset. We will likely encounter subqueries in any real-world setting that uses relational databases. For example, calculate triple the average home plus away goals scored across all matches. This will become our subquery in the next step. Note that this column does not have an alias, so it will be called column in your results. So select the average of home plus away goal multiplied by 3. So simply type select 3 static average into home goal plus away goal from matches 2013 to 2014. Next is filtering using a subquery with a list. In this exercise is to generate our goal is to generate a list of teams that never played a game in their home city by using subquery. Create a subquery in the where clause that retrieves all unique home team ID values from the match table. Then select the team long name and team short name from the team table. Exclude all the values from the subquery in the main query. So select the team long and short names. Select team long name, team short name from team with team API IDs not in. Select distinct home ID from match. Filtering with more complex subquery conditions. In this exercise, in previous exercise, we generated a list of teams that have no home matches listed in the source database using subquery in where. For example, create a subquery in where clause that retrieves all home team ID values from match with home goal score greater than or equal to 8. Then select the team short or team long name from table. Include all values from subquery in the main query. So select team long name, team short name from team where team API ID in. Select home team ID from match where home goal greater than equal 8. Next is joining subqueries in from. In this exercise, our goal is to generate a subquery by using match table and then join that subquery to the country table to calculate information about matches with 10 or more goals in total. For example, select country ID from match where home goal plus away goal is greater than equal to 10. Add a subquery in from in the next step. In this exercise, we will turn the main query into subquery to extract a list of stages where the average home goals in stage is higher than the overall average for home goals in a match. For example, select S stage round S average goals to as average goals. Then select stage home goal plus away goal as average goals from match where season is 2012-2013 and group by as S where S average goals greater than select average home goal plus away goal from match where season is equal to 2012-2013. Next, the third chapter is correlation, subqueries, nested subqueries, and common table expressions. In this chapter, we will learn how to use nested and correlated subqueries to extract more complex data from relational database, and we will also learn about common table expressions and how to best construct queries using multiple common table expressions. This chapter includes the multiple functions, for example, basic correlated subqueries with multiple conditions, nested simple subqueries, nest a subquery in from, organizing with cities with nested subqueries, get team names with subqueries, and at last, get team names with cities. In the first lesson, we will talk about basic correlated subqueries. First, we know what are correlated subqueries. Correlated subqueries are subqueries that reference one or more columns in the main query. So, it depends on information in the main query to run and thus cannot be executed on their own. For example, select the country ID, date, home goal, and average goal columns in the main query. Next, complete the average value in the subquery, then complete the subquery column reference so that country ID is matched in the main and subquery. Correlated subqueries with multiple conditions. Correlated subqueries are useful for matching different data across multiple columns. In the previous exercise, we generate a list of matches with extremely high scores for each country, but in this exercise, we are going to add an additional column for matching and nested simple subqueries. What are nested subqueries? Nested subqueries can be either simple or correlated, just like an unnested subquery. So, a subquery nested subqueries components can be executed independently of the outer query, while a correlated subquery requires both the outer and inner subquery to run and produce results. Next, nest a subquery in from. For example, generate a list of matches where at least one team scored 5 or more goals. Select country ID season from match where home goal greater than equal to 5 or away goal greater than equal to 5. Clean up with cities. For example, complete the syntax to declare your city. Select the country ID and match ID from the match table in your city. Then left join the city to league table using country ID. Next is organizing with cities. For example, expand on the exercise by looking at details about matches with very high scores using cities. Just like a subquery in from, you can join tables inside a city. For example, declare your city where you create a list of all matches with language name, league name, L dot name as league, M dot date, M means main, query, M dot home goal, away goal, and home goal plus away goal as total goals from match as M. Then left join league as L on country ID is equal to LID. L means league. Then select league, date, home goal, away goal from match list where total goals greater than equal to 10. Get team names with subqueries. For example, create a query that left joins team to match. In order to get the identity of home team, this becomes the subquery in the next step. Select m.id t.team long name as home team and then from match as m, left join team as t on home team id is equal to team API id. Get team names with correlated subqueries. This can easily be performed using correlated subqueries. For example, select mdate from team as t where t team API ID is equal to m home team ID as home team from match as m. Get team names with cities. For example, select ID from match and team long name from team. Then join these two tables together on home team ID in match and team API ID in team. Select m.id team long name as home team from match left join team as t on m home team id is equal to team API ID. And the is last chapter is window functions. In this chapter we will learn about window functions and how to pass aggregate functions along a data set. We will also learn how to calculate running totals and partitioned averages. So this chapter includes partition by a column, partition by multiple column, and sliding windows. First is partition by a column. Partition by clause allows you to calculate separate windows based on columns which you want to divide your in which you want to divide your results. For example, you can create a single column that calculates an overall average of goals which are scored for each season. Next is partition by multiple column. Partition by clause can be used to break out window averages by multiple data points means columns. We can even calculate the information we want to use to partition our data. For example, we can calculate average goals scored by season and by country or by the calendar year taken from data call. Then sliding windows allows us to create running calculations between any 2 points in a window using functions such as preceding, following, and current row. We can calculate running counts, sums, averages, and other aggregate functions between any 2 points you specify in the dataset. This is the certificate which I gain on accomplishment of this course on April 19, 2022. That's all from my side. Thank you.